award-winning, thank you, an award-winning smartphone app and a NIDA, National Institute on Drug Abuse, funded grant, and whose purpose is to reduce relapse and opioid use disorder. And in particular on how neuroimaging can inform mechanisms of action for this and other interventions. Big shout out to all the Berk people, raise your hands. Yay, you have a whole fan club here, Andy, as well as the rest of us. We're also your fans. All right, welcome.
All right, well, thank you, everyone.
Wait, I have to play Andy James here. Would you prefer to hold questions till the end?
You can interrupt, feel free to ask questions during the presentation, although I do have time at the end.
And the CME information is in the chat. For those of you who are here in person, it should be in your invitation that you should find in your calendar to text the code to get CME credit. And this is being recorded, correct?
Yes. Okay. Thank you, Dr. Dunn. So we have the CME credit here on the screen. We have 3 objectives today. One is to describe our NIDA award-winning app Optimat as an adjunctive therapy to prevent opioid misuse. I feel like I'm getting some feedback among patients receiving MAT for opioid use disorder. I'll step away from the mic, but if you can't hear me, let me know, especially those of you online. Secondly, to review brain changes associated with the development of addiction as well as recovery from addiction. And finally, to demonstrate how functional neuroimaging can inform treatment outcomes in opioid use disorder. Now, I have a hidden stealth objective, which is to explain to you how functional MRI works. So MRIs are very powerful magnets, 300,000 times stronger than Earth's magnetic north. And using MRIs, we can study brain structure, typically by looking at the concentration of hydrogen atoms, the most abundant atom in the brain, and the effects of tissue density, volume, et cetera, on the magnetic properties exerted by hydrogen on surrounding tissues. We can also use MRI to study brain function in a technique known as functional MRI. So for the typical functional MRI experiment, we have participants lie supine on their backs in the MRI, and we present stimuli to the participants. These could be visual stimuli presented via image projector or an MRI-compatible television. These could be auditory stimuli, such as from a MRI-compatible headphone. It could be tactile stimuli, such as vibration or electric shock. And we typically record participants' responses during these experiments. Most commonly, we use a button box where they can make a motor response. In the Berk, we have an MRI-compatible digital microphone, so we can record verbal responses during the experiments. And we collect images of their brain, participants' brains, and analyze them over time to study time-based changes in brain activity corresponding to our experimental paradigms. We can do all of this thanks to this molecule. Does anyone want to hazard a guess as to what molecule we're looking at? I'll give you a hint, it's hemoglobin. So hemoglobin, as you recall, is responsible for carrying oxygen throughout the bloodstream. It does so thanks to these 4 heme subunits, color-coded here as they appear in nature, each of which has an iron core and each of which is capable of binding oxygen. So in its deoxygenated state, hemoglobin, that iron core in each of these heme subunits exerts a magnetic influence on surrounding tissues that we can detect with a powerful magnet. But once hemoglobin binds oxygen, oxygen's electronegativity masks that magnetic influence and becomes invisible, magnetically invisible. So at any time, so within the brain, for each individual, there's some ratio of oxygenated to deoxygenated hemoglobin. And when neural activity occurs, 2 things happen. First, local hemoglobin gives up its oxygen to supply the surrounding neural tissues. You remember the Krebs cycle, neurons firing, et cetera. This occurs over the course of a second, and when oxyhemoglobin gives up its oxygen, it enters a deoxygenated hemoglobin state, which we can then detect with a powerful magnet. But the body responds 2 to 6 seconds later by sending an influx of oxygen-rich blood to replace that oxygen which was consumed And the body overreacts whenever the brain needs oxygen by shunting about 10 times more oxygen than was consumed to replace that consumed oxygen. We call this the blood oxygen level dependent or BOLD response, which has a peak of about 4 to 5 seconds post-stimulus and a return to baseline about 10 to 12 seconds post-stimulus. And it's a signal change of about 5% that we see. In fact, this initial consumption is so low that this is an older figure. For decades, we debated whether or not you could actually see that initial consumption of oxygen. With newer scanners and better technology, yes, you can. But at the time of this publication, we didn't have that resolution. So with functional MRI, we're taking snapshots of brain activity as people undergo this experiment. When I started in this field in 2000, we were limited to whole brain resolution, a whole brain snapshot every 3 seconds. But with modern technology, we're down to 800 milliseconds. And we can map out changes in brain activity throughout the course of an experiment. So one of the simplest tasks would be a finger tapping task where a subject alternates between keeping their hands still or tapping their fingers for 20 seconds. On top, we have an activation map showing brain regions that are more active during finger tapping than not. And it's a very nicely lighting up the motor cortex. And in the bottom, we have a mean time course of brain activity of those voxels in red, of those brain regions during the task. We can even look at the brain response to individual events. So this is work I did at Emory University through a small grant from the Coca-Cola company, modeling the neural basis of aftertaste perception. This is the first paper to model the neural basis of aftertaste. It was important to them because non-caloric sweeteners like aspartame have a higher binding potential K value to the taste buds. And it creates a longer aftertaste than natural sweeteners like sucrose, which many people find unpalatable. So they wanted to figure out how the brain processes aftertaste for their taste testing studies. And surprise, surprise, it turns out the insula, the primary taste cortex, is also the primary aftertaste cortex. So it wasn't a revolutionary finding. If you think it was nice to confirm that. But I highlight this study because it was by far one of the most technically demanding studies I've led. It involved creating an MRI-compatible juice delivery device, so no ferromagnetic components, programming the software for millisecond delivery of the solutes. You also had to find really long straws, which sounds facetious, but actually was a challenge to find tubing that wouldn't dribble all over the participant while they're lying on their back in the MRI. But as technically challenging this was, as great a puzzle as this was to solve, at the end of the day, I'm not helping people, unless you count corporations as people, which I do not. So in 2009, when our founding director, Clint Kiltz, invited me to come here to Arkansas and build the state's first research-dedicated human MRI center, specifically addressing the clinical needs of Arkansans, I leapt to the opportunity. It was a great opportunity to take this technology and actually use it to inform health decisions. And I have to give thanks to Helen Porter and Jim Dyke, our founding Burke contributors, whose vision made the Burke possible. One of those challenges is the opioid crisis. As I'm sure you're aware, that we're in the midst of an opioid overdose crisis. Last year, in 2022, over 209 people died daily in the United States from opioid overdoses. This accounted for 70% of all U.S. drug overdose deaths. And rural states are particularly hard hit due to the perfect storm of higher opioid dispensing rates and reduced healthcare access, resulting in rural opioid-related mortality up to 4 times greater than urban areas. And Arkansas is no exception, having the second highest opioid dispensing rate, 72.2 dispenses per 100 people last year. Medication-assisted treatment for opioid disorders is our best treatment for helping people struggling with opioid addiction. This consists of opioid substitution using methadone, buprenorphine, or Suboxone to promote recovery by alleviating withdrawal and craving symptoms. Although it is effective, an estimated 40% of patients will relapse within 1 year of starting MOUD. So in discussing this issue with our colleagues here in psychiatry, we turned to smartphone apps. There's a variety of apps available to promote healthy behaviors, whether it's weight loss or smoking cessation or reduced alcohol use. And all of these use the same principles of counting, monitoring your behavior, whether you're counting steps or counting calories or counting cigarettes, and providing personal reinforcement to change those behaviors. And at the time, this technology had not yet been applied to medication-assisted treatment for opioid use disorder, particularly in rural states. So my colleagues are Ron Thompson, who has experience developing smartphone apps, and Mary Bollinger, who is a demographer, both of whom are in the Center for Health Services Research. Mike Mancino, who's the director of the Center of CAST, and Clint Kiltz in the Burke. We all got together and brainstormed the solution, which we got funding in 2021 as a R01, to develop and evaluate a smartphone app to prevent relapse in opioid use disorder, and also to look at the neurocognitive mechanisms underlying the recovery process. Now, at the time, it took us a year to actually build the app. And once we finished completing it, we learned about a national challenge through challenge.gov. Now, if you're not familiar with challenge.gov, I recommend you going to this website. It is an effort by the federal government to crowdsource solutions to various problems facing Americans. For example, there's currently a challenge.gov request to find solutions to promote cybersecurity against cyber attacks. They're looking for better solar panels and ways of getting carbon dioxide out of the air. DHHS is looking for ways of studying race and ethnicity and medical records, electronic health records. So there's a wide variety of different challenges available, and anyone can apply for these. One of these was sponsored by NIDA, and that is the Product Prototypes to Combat Drug Craving Challenge. And for this, they were looking for prototypes to decrease drug cravings and prevent relapse. They specifically wanted prototypes that were easily accessible and minimally invasive, that were available just in time and on demand, that were suitable for use without detoxification as a requirement for use, that were substance agnostic, i.e. could be applied to patients with any type of substance use disorder, that were suitable for many different patients, different ages, genders, geographic locations, and incomes, and at different stages of recovery, and that were multifaceted and modifiable with different options where patients could tailor their interaction level or the use of the intervention based on their individual needs. So we had just finished developing our app, and this seemed to be a shoo-in for what we were doing. So we applied. Now, the application process was a 5-minute Shark Tank style video, which I would say I would recommend that NIH completely ditch the grant application process and go purely toward 5-minute Shark Tank videos, because this was quite a bit of a challenge and quite a bit of fun to put together. We had to flex some creative muscles that we haven't used before. So rather than me tell you about the app, I'm just going to show you the app. And those of you online, if you cannot hear the presentation, please let me know. This will take about 5 minutes. Hi. I'm neuroscientist, Dr. Andy James.
I'm behavioral scientist, Dr. Ron Thompson.
And I'm demographer, Dr. Mary Bollinger.
And we've created
Optimat,
a smartphone app to optimize medication-assisted treatment for opioid use disorder.
We developed Optimat as a tool to reduce opioid cravings and subsequent relapse among patients receiving medication-assisted treatment, or MAT, for opioid use disorder. We will evaluate Optimat through a clinical trial at our home institution, the University of Arkansas for Medical Sciences. Optimat combines daily monitoring of craving and mood with personalized feedback to reduce opioid misuse. To get started, participants press the plus sign at the center of the bottom banner to complete their daily monitoring report. During this report, they are asked to rate their experiences for the previous day. They are asked, did you take your medication for opioid use disorder yesterday? How strong was your opioid craving yesterday? Here they can move a slider to indicate the severity. How strong were your withdrawal symptoms yesterday? Also a slider. Did you use opioids yesterday? If they respond yes, they are prompted to enter the amount spent. Next, they are asked about mood. How depressed were they? How stressed were they? How angry? We also ask about comorbid use of alcohol and marijuana. If they report use of alcohol, they are prompted to enter the number of standard drinks using NIAAA guidance for alcohol equivalents. Since standard equivalents don't exist for marijuana use, if participants report using marijuana, we simply ask how many times. After completing their daily report, participants see a summary of their responses. They can make corrections or submit their report. After submitting their daily report, participants then get personalized feedback based on their responses. The feedback they received is based on 2 points of branching logic. Did they lapse in their opioid misuse? And how strong was their opioid craving? For example, participants who lapsed and reported high craving will be encouraged to follow up with their provider to see if their medication dosage needs to be adjusted. Participants who did not lapse but still report high craving will be congratulated and recommended activities to reduce craving. We are currently piloting Optimat among patients receiving MAT for opioid use disorder who are helping us write personalized feedback statements that they as clients would find valuable. On the home page, participants can review their badges earned for Optimat use. Note that we are rewarding app use and not opioid abstinence so that clients are not punished for honestly reporting their daily experiences. We also show a random item from their tip bank for encouragement, a summary of their opioid use and craving over the past week, and their personalized support network, whom they can call if they feel that they are at risk for lapsing. The personalized support network consists of up to 3 friends, 911, and Arkansas 211, a state service for non-emergency assistance. On the progress page, participants can see their opioid use and spending for the past week and their opioid craving and withdrawal severity. We also include reports on marijuana and alcohol use. Clicking on any of these provides a detailed report of their behavior for the past week. On the resources page, participants can view motivational tips from the tip bank. Participants can also customize the tip bank to add their own strategies for reducing craving and avoiding opioid misuse. They can also find local emergency treatment and services. Finally, they can get verified information from the NIDA webpage about drugs of abuse. On the profile page, participants can customize app features including the members of their support network, a reminder for their next research appointment and clinical appointment, and a daily reminder to complete their tracker. We also know that craving is context dependent, with some places evoking stronger feelings of craving than others. These are typically places that clients associate with opioid craving, purchase, or use. At study intake, Optimat users will identify up to 5 places where they are at greatest risk for relapse, which we call hotspots. Using Google Maps technology, we can build a geofence around each hotspot. We can adjust the geofence radius to account for the location's urbanity or rurality. Entering the hotspot triggers a cascade of just-in-time interventions. First, participants are immediately prompted to leave the area. If they remain in the hotspot for 5 minutes, then they are prompted to rate their current opioid craving severity. If they rate their craving at 70% or higher, or if they remain in the hotspot for another 5 minutes, then they will be prompted to contact a member of their support network. Study staff will be alerted to this just-in-time intervention and will reach out to the participant on the next business day. We believe Optimat's combination of daily monitoring, personalized feedback, and tailored just-in-time intervention will help patients in MAT for opioid use to decrease their opioid cravings and maintain their abstinence. Thank you for considering us for the NIDA product prototypes to combat drug craving challenge.
All right, and there's nothing more cringy. Oh, thank you, thank you. Nothing more cringy than listening to yourself talk. So a bit of a spoiler. Oh, no, I was not gonna do that again. So, yes, so our prototype was named one of the 5 national winners of this particular drug craving challenge. And I noticed we're the only one who's not a biotech startup. So should I be building a biotech startup? I don't know. But after this, this announcement came out around the same time as the College on Problems and Drug Dependence was accepting submissions for their 2023 conference. So I had a pretty good idea, one of the better ones I've had in my career. I reached out to the first and second place winners and invited them to join me in a symposium at CPDD, and they accepted, and we were accepted to give the symposium. So I had a big ballroom presentation of like 200 people present, talking about, each of us talking about our particular interventions for this drug challenge. So to tell you a little bit more about the randomized control trial, which we're using to evaluate the app, we're currently recruiting 256 participants who are receiving MOUD. We're specifically looking for patients in phase 1 who come in weekly for their appointments, which is typically people who have started in the past month. We're currently recruiting from 5 sites within the UAMS Matriarch Network. Participants who agree to be in the study are randomized to one of 2 study arms, either an arm where they use Optimat in addition to their MOUD, or one where they just have MOUD alone. We are stratifying our randomization by study site, by experience of chronic pain, low or high, and by comorbid use of alcohol or marijuana, yes or no, since these factors may influence treatment outcome. And our outcome measure is urinalyses, percent urinalyses negative for opioids of all total possible clinically acquired urinalyses tests during the duration of the 6-month trial. And we've published our clinical trial registration. So if you want all the gory details, statistics and whatnot, here's a link here. So we're currently recruiting from 5 sites. Our primary site is CAST here at UAMS in Little Rock. We also have the Compassionate Care Clinic of Searcy and Counseling Services of Jacksonville. We just added 2 new sites this month, River Valley Medical Wellness in Russellville and River Valley Medical Wellness in Hot Springs. And we're really looking for a mix of both urban and rural sites so we can, as a secondary aim, look at the effects of rurality on treatment outcome. But I'm a neuroimaging scientist, and my passion is understanding cognition and how the brain encodes cognition. So I'm going to shift gears a little bit and tell you more about how we're using brain imaging to study treatment outcome, both cognitive processes and biological processes that change with addiction and which change with recovery from addiction. So there's a host of cognitive changes that occur with the development of addiction. The 3 most prominent are depicted here. There's also emotional changes, mood changes. I'm not going to go into those. One change is greater attentional bias for drug cues. So drug-related stimuli are harder to ignore, and patients will find or people dealing with drug use disorders will find their attention drawn to these drug-related cues. There's also changes in reward function, where drug-related cues become more rewarding and non-drug cues become less rewarding. And there are self-directed behaviors such as thinking about, ruminating upon, and pursuing drug cues. With recovery, we see a reversal of these changes. So here in blue, we see that the heightened attentional bias for drug cues decreases back to normal levels, depicted here by the dorsal anterior cingulate, dorsal insula bilaterally, and inferior frontal gyrus bilaterally. We also see a normalization of reward function. So those drug cues become less rewarding and non-drug cues become more rewarding, depicted here by a variety of striatal regions, nucleus accumbens, putamen, et cetera, and ventral insula. And specifically for motivation-based interventions, we see increased engagement of the default mode network. That's that region of that network involved in rumination and introspection, thought, et cetera. Depicted here, medial prefrontal, posterior cingulate, and precuneus. But what is the temporal order of these changes in brain function and the corresponding changes in cognition and recovery? I think this is important because, my personal theory is that first, in the early stages of recovery, patients are better able to ignore the drug cues. And over time, once they strengthen that attentional control, reward systems follow and normalize. But it could be the reverse. It could be that prolonged abstinence leads to changes in the reward functions of these cues, of these drugs, which in turn makes them easier to ignore. So it's a bit of a chicken and the egg, or they could be completely independent. They could be two parallel processes. But if there is a temporal order, it could help us to understand and develop better interventions that target one of these over the other. So we also have a functional MRI study with 3 longitudinal time points acquired at intake in month 0, 2 months later, and 4 months later to predict outcomes at the 6-month endpoint. We also have monthly timeline follow-backs to get self-reported measures of drug use behavior. So we have a variety of tasks that we use to measure attention, drug-related rewards, and non-drug rewards. To measure attention, we use the counting Stroop task, which is a measure of attentional bias. And this is a pretty simple task. The subject is lying in the scanner with a button box with 4 buttons, and they press button 1 through 4 based on the number of words that they count on the screen. So we have a neutral condition, like the word chair, presented 3 times. They press button number 3. Sometimes we throw them a curveball. We have an incongruent condition, like the number 4 presented once. The correct response is 1, because there's 1 word, but we're hardwired to, we're really good at counting. So our natural inclination is to press button number 4 due to the word 4. For people with drug use disorders, we can provide craving cues. And it's important that these craving cues are personalized to their specific drug use behavior. So for someone who injects crack cocaine, we would give them a word like spoon. Again, if they use spoons as part of their paraphernalia. Here, the word spoon is presented twice, so they press button number 2. It's important to note that many of these craving cues would be neutral cues for non-drug using participants. So this is a study that Clint Kiltz and I did in the context of cocaine use disorder, published back in 2014. We recruited 42 participants with cocaine use disorder, and we found that, I should explain the task. These distracting cues slow people down. So the more that you are distracted by the particular cue, whether it's an incongruent number word or a craving related cue, you are slower to make a response. And in this task, our craving cues and incongruent participants had significantly slower responses for both the incongruent cues and the craving cues relative to neutral cues. And what's interesting is that if we look at this attentional bias network, and you can kind of see the theoretical regions from the Zilverstand review up here, dorsal anterior cingulate, bilateral insula, the magnitude of brain activity in this attentional circuit positively correlated with the increased slowness or the distractiveness of our drug-related cues in our cocaine-using population. So we've adapted this task for our opioid neuroimaging study. So again, we have neutral cues, incongruent cues, personalized craving cues, but we've also added in personalized sobriety cues, like the word mom in honor of Mother's Day, which, by the way, public service announcement, Mother's Day is Sunday. If you need to run out to order some flowers, I understand. So we can look at not only craving cues, but also sobriety-related cues. We piloted this in 3 participants prior to getting the grant to see if this task would work. These were all 3 participants receiving medication-assisted treatment for opioid use disorder, all of whom had been abstinent from opioid misuse for over 12 months. And in this sample of 3 people, we found that yes, they were slower for incongruent versus neutral cues, p-value 5.6 times 10 to the -8th. That p-value is equivalent to tossing a coin and having it come up heads 25 times in a row. So yeah, it could be due to random chance. It's probably not. We also found, quite interestingly, we found slower reaction times for sobriety cues relative to neutral cues. It's only a p-value of 0.001. That's like 10 coin tosses, weak sauce. But most interestingly, in this sample of abstinent patients, we found no difference between craving and neutral cues. Reaction time, 7 milliseconds, not significant. So that's pretty interesting. And I'm intrigued that the sobriety cues are getting a reaction time response and not the craving cues. Maybe this is some form of extinction learning. Like maybe as craving cues decrease, sobriety cues will increase. The sobriety cues are overriding the craving cues. That's totally speculative, but that's something we can test with our longitudinal design. Looking at brain data, these are the same 3 participants. And again, on the left, we have regions identified for cocaine use disorder as encoding cocaine craving. For incongruent versus neutral cues, we see bilateral insula in yellow and dorsal anterior cingulate in blue. Greater activity for the incongruent versus neutral cues. We see the same pattern for sobriety versus neutral cues, also maybe a hint of caudate, but no differences for craving cues. Again, a rather interesting finding in these absent individuals. So now that we're recruiting participants for a randomized control trial, once we have a sufficiently large sample, we can start looking at that. Yeah, Dr. Brents. Oh yeah, please interrupt. Thank you. Yes. The question is, what makes a cue a sobriety cue? Well, we asked the participants at intake on the day of the MRI scan to list the top 10 reasons for being sober, people, places, things, locations, and then we have them then rank like the top 6. So we use those top 6 personalized cues that the participants provide us. Same for the craving cues. Oh, and we also do a check if by chance our neutral cues are like desk, window, hallway. I mean, they're not all office locations, but we make a check that the neutral cues do not include craving or sobriety cues. And now we have 2 other tasks to look at reward. One is a craving task looking at opioid-related reward. And for this, we're using the methamphetamine and opioid cue database, a relatively recent development by Dr. Psychiatry at Tulsa, with the Laureate Brain Institute in Tulsa. And this is a collection of images depicting neutral items like tools and objects, opioids and methamphetamine. We're only using opioids for this study, obviously, but for people doing methamphetamine research, we also have a set of cue images for that types of research. What's interesting, I love this photo set, this image set, because they actually standardize the images. So they have images of the tools or opioids alone, images of people handling the tools or objects or opioids, people using them. So you can look at different contexts, but they're very nicely paired. And so for this study, we show participants blocks of 6 images, either neutral blocks or opioid blocks. At the end of the 6 images, the participant rates their current craving intensity on a 1 to 4 scale. And then at the end of the study, we have them rate all the images they saw for post hoc analyses of the brain response to individual events versus the blocks of events. Again, we piloted this in our 3 participants, and they reported higher craving for the opioid cues relative to the neutral cues. Now, the median craving was a 2 on a 4-point scale, so it's not much larger than neutral. But again, these are patients with long-term abstinence, and this is quite a significant finding. When looking at brain activity, we found greater activity for the opioid cues in this orbital frontal region, part of a reward network. Not so much for ventral striatal and other striatal regions, which is a bit surprising. But again, it's 3 participants. So that's something which we'll have to look at in our full sample. And I guess I should take an aside. There's some debate in the field as to whether orbital frontal relating craving is part of the reward network or is it its own type of cognition. different people have different thoughts, and I'm not getting in the middle of that debate. So that's just one of those long-standing debates in the field that I'm trying to sidestep as quickly as possible. Finally, we can look at reward functions. So for this, we're using the monetary incentive delay task, a very popular and standardized task for studying reward function. For this task, participants see one of 5 cues where they could win $5, win 20 cents, not lose $5, not lose 20 cents, or a neutral condition where there's no money at stake. They see one of these cues, it disappears, and it's followed by a black box, a probe, and they have to press the button as soon as the probe appears. If they're fast enough, they will either win the money or not lose the money. If they're too slow, or if they respond too fast before the probe appears, then they don't win or they lose. So this is a test looking at both reward and loss at different magnitudes. And we titrate this to ensure about a 60% success rate. So we have a mix of both successful trials and non-successful trials for each individual. And this task has been shown to, robustly activate the ventral striatum, as we can see here by the green area.
Andy, we lost the audio.
We're back on. We heard, yeah. Oh, I thought that was him. Sorry.
Well, we're almost done. We're almost done. So, well, they can't hear me.
We can hear you.
Oh, you can hear me.
Be careful.
Solved it. How do I make this go? Let's go. Oh, no. Okay, well, we're just going to have to put this over here. How about this little thing? Oh, well, yeah, that's much better. Oh, here's an arrow. Let's do that. Okay. So we have a task to study reward function. Yes. And I'm going backward. I'm backsliding. Okay, so how does the brain change with recovery? And does Optimat usage moderate these changes? So a larger fundamental question is, what is the timing of these brain and behavioral changes in both attentional control and reward function? And if one precedes the other, could this be a focus for future interventions? But also, how does Optimat itself influence recovery? Do we see differences between those individuals who used Optimat while undergoing MOUD versus those people who are in MOUD only? And specifically for individuals in the Optimat arm, well, the first question, that's the focus of the clinical trial. So I hope we see a difference, and I hope it's in the direction we expect. But for individuals who are using Optimat, how does feature usage influence outcomes? So does daily use of Optimat influence outcomes? Does the participant's behavior when they enter hotspots or the frequency with which they avoid hotspots influence outcomes? Does their usage of the tip bank influence outcomes? Does calling the support network influence outcomes? We're also acquiring qualitative feedback at the end of the 6-month trial to improve Optimat's features in the next grant/national rollout. Oh, there we go. Like, for example, when piloting this, when collecting pilot data for our grant, we recruited 11 participants from CAST, and we monitored their usage. So we saw pretty high usage, around 50% daily usage of Optimat in the first month, which dropped to around 20% in months 2 and around 15% in months 3. These are significant decreases, but what's really fascinating is that you can see quite a bit of individual variance in how participants used Optimat throughout the first 3 months. This one participant, 12, was a diehard user and was committed to using it every single day. Some people would have usage patterns that then drop off. Some people would take breaks. So, in the clinical trial, we'll be able to correlate daily usage with negative urinalyses or entering hotspots or other factors to try to get a more holistic picture of what's going on in these people as they are in recovery for opioid use disorder. Finally, we have Mary Bollinger, who's our GPS guru. So we're collecting GPS measurements every minute. So we can also use location-based information to identify neighborhood stressors which might influence opioid relapse. And this is not a new topic. There's a publication here from 2005, but the technology for measuring location-based influences has improved. So we can factor in geographic variables into our analyses to predict outcomes. Now, I'm also interested in learning if brain activity at baseline might predict outcomes. So is there some brain feature which might better predict individuals who are on a better chance or have a better chance of recovery versus those who might need a more in-depth intervention? This is work collected here at UAMS and the Center for Addiction Research. It's an early grant that we had with Kathy Stanger and Alan Budney, in which adolescents with alcohol or marijuana use disorder underwent brain imaging prior to their enrollment in a 6-month therapy. And in this recent publication by our former trainee, now a professor at University of Florida, Amanda Elton, found that brain activity prior to treatment could predict the percent of positive urinalyses over the 6 months of treatment. And specifically, it's the involvement of this default mode network that we talked about, involved in introspection and self-reflection, the extent to which it was pulled into reward networks predicted outcome. So that's something else that we could look at in this work. So I want to give a shout out to open science. So the beauty of this is that, the Berk has recently fully embraced open science, and the entire data set we collect, all the brain data, all the behavioral data, will be de-identified and sent to the cloud for anyone in the world to analyze and check my math. Spoiler, it's correct. But it's there for people to look at. And I have to give a shout out to Megan, Dr. Calvert, who's leading the Berk's open science and reproducibility initiatives. Finally, thank you to the Berk, who do all the heavy lifting in this, and also my aforenamed colleagues. I am giving Research Matters 2 Thursdays from now at noon in the Education Library. I don't know the topic, but it will be entertaining, so please attend if you can. And finally, the Berk is having a happy hour, so I am here until 4:59 sharp, and then I am leaving. I will walk out mid-question if needed. So, but in the meantime, you got me for 12 minutes, so I'm happy to answer whatever questions you have. Dr. Atchison. The question is, do we have a measure for motivation to be engaged in treatment, like a treatment to change measure or a perceived need scale or something like that? We do not. Maybe that's something we could either add in or include in the qualitative survey at the end of the 6-month period. Unless there's something collected clinically, I don't know. I mean, we could look at number of group visits attended, number of missed appointments, maybe something like that. I don't know. That's something I'll talk with the collaborators and see what we can come up with. Mhm.
For some reason, engagement in treatments may decrease in this for some people, right? And so you're looking at how there's like the app, you're trying to sort out like what role the app is playing in that.
Mhm.
I'm not sure really how to tease it apart, but it's just like, you kind of have, you can imagine, let's say, one way that as people are less likely to feel less effective treatment, they're less likely to respond to the app. Or it could be the reverse, that like say if people are, like if they're more engaged with the app, that could be encouraging them to stay in treatment longer. So how to kind of tease those things apart is.
Yeah, there's an ongoing discussion about how to tease that apart, how to get to that motivation component for those of you online. So I'm open to suggestions. If anyone has an idea, I'd be happy to hear some thoughts about that. Dr. Wolf. Mhm. Yes, so and that's so I'm going to give the answer, then repeat the question. I'm going to go out of order here. So that is one of the challenges in neuroimaging when dealing with clinical populations is that how do we know that the attentional network itself isn't different within these patients? And maybe with recovery, we see a conformational change in that network. For example, increased communication between different brain regions. That is easily something that we could look at. Typically, we would do an independent component analysis, pull out all our brain networks for the group, and then look at individual variants within that network. In the Burke, we're very much focused on brain networks rather than individual regions because the brain is an ensemble of regions working together toward an outcome. But that is something we could do, and that is actually what Amanda looked at. So this is not brain activity, but the extent to which a reward network recruited brain regions was predicting outcome. So that is definitely an analysis that we can do. Dr. Oliveto.
Lovely, very exciting. And my question, because I saw that you're stratifying based on alcohol and on marijuana use. However, as in Arkansas, it's like 30% of people get trained and have a problem.
Oh, yes. Mhm.
We are participating in a NIDA health network trial, investigating different medication strategies for disorder and how that impacts attention. We have found many of our folks coming in with dual use who may stop their opioid use, but they are going to town with methamphetamine use and ultimately will like stop being in the study.
Mhm.
And then we have a
Oh, goodness.
so how are you guys getting all the during the fall?
Mhm.
And just something to be considering with this, because that's a lot bigger than other places, depending on where you are.
Yes. The question is, what about comorbid use of methamphetamine? And currently, methamphetamine use is exclusionary. So these are only people who report opioid use and or alcohol or marijuana. But that could be a valid sub-study, especially as we see shifting trends. Addiction is a moving target. It's like, you tamp down on one drug of abuse and people start using xylazine or, fentanyl or other drugs. So you have to kind of really roll with the punches and adapt the methodology. And that's one of the challenges of the clinical trials, that we kind of have to stay within the guidelines. But I will say our urinalyses test, they test for Everything? Dr. Mancino, whoa, testing. Okay, now the sounds, okay. Yes, I'm going to try to talk away from the microphone. I don't know if you can hear me online. But yes,
Oh my God.
yeah, okay, so I think it's happy hour. So thank you all for your time.
I know you just